Okay, clarification video attempt number 2. Hello, it started off with this video and I got a comment from Walter Bislin. Here it is. I came up with the idea for this video when I was on the toilet and I did a bit of quick math. Turns out the first geolocation that I had picked happened to be at Union Glacier, which was fairly close to being a consistent 15 degrees per hour. And after I analyzed it a little bit more and made video part 2, I realized that I had to transform the direction. So the crux of the matter was that the meme was saying that they were only looking at the altitude angle and not counting the azimuth. And because of that, they were not deriving a constant 15 degrees per hour. In the first video, I thought that I was going to look at both altitude and azimuth. And then I realized that there were some other factors going on, which made me put out this video where I was taking the altitude and azimuth reading and projecting it out into 3D space. You can imagine a stick of a unit length of 1. The end of the stick that stays stationary could be the origin, and the other end of the stick would be relative to that origin, and you would project that out into 3 dimensions. In this case, I have x-axis running as east-west, y running as north-south, and z running up and down. And what this spreadsheet demonstrates is that if you then rotate on the x-axis, so you're transforming the y and the z-axis based on your latitude, and then you get a new normalized xz angle, by calculating the difference between these two angles or these two different times, you will get an angle delta. In the case of my spreadsheet, I've got that set up as being every 12 seconds. Then I have to take that angle delta in that 12-second interval and convert it to degrees per hour. And when I was doing that in the spreadsheet, you could see that in every case, it was pretty close to exactly 15.0 degrees per hour. In fact, that value changes depending on the time of the year due to the Earth's elliptical orbit around the sun, and the Earth speeds up and slows down as it goes around the sun. That's what I was trying to accomplish in this video with this spreadsheet. And then I got this comment. And I just wanted to make this clarification video that you're watching now to hopefully remove every last bit of doubt as to what I'm trying to do. So I created a new animation. In this case, what I'm trying to do is I'm trying to show that we live in 3 dimensions and that in each of the dimension axes, you've got the X, which happens to be east-west. You've got the Y, which happens to be north-south. And you've got the Z, which happens to be up and down. And that you can rotate on the one axis. In this case, it was the Z axis. Then you can rotate on the Y axis. And then finally, you can rotate on the x-axis. And this is the axis in question that I was trying to demonstrate how you would accomplish this. You'd be rotating on the x-axis away from the equator. So perfectly straight up and down, you would be at the equator. Leaning towards the north, you would be in the northern hemisphere. And leaning towards the south, you'd be in the southern hemisphere. The angle at which you would rotate would happen to correspond to your latitude. And in the video that I had made and took down because it wasn't quite clear enough, I chose 2 different days, 3 different latitudes for the same longitude. And I showed that process in a nice nifty animation. I'm going to play those animations. The other point that I wanted to make in that video that I took down was that it's very easy for us to use an altitude and azimuth coordinate system to locate something in the sky, generally because we're standing on the ground and the ground seems to be our point of origin. An equatorial mount is actually more geared towards the proper coordinate system for looking at things in the sky, which is right ascension declination. And the last video was to show that you could transform one coordinate system to the other and still derive 15 degrees per hour. In fact, it also reminds me of something else that Walter Bislin did, which was his interpretation of the azimuthal grid of vision thing that Whitsitt came up with that tries to explain the bendy light, when in reality you can see that it really is right ascension declination being rotated for the local observer. I hope this video was clear enough. I did get a comment from someone saying that they enjoyed my animations and they wanted to do something similar. I thought I was going to make another video describing how I make these Pavre-based animations. In that video, I'll probably leave a link to a copy of this script here. Anyway, that's going to be it for now. Thank you for watching. If you like the video, you know what to do. And as always, if it's really not clear, let me know and I'll try to do better next time. Bye for now.